Ready, thank you, Ellen. Well, hello there, AireSpring world. How are we doing out there? I think most of you know me or have talked to me at one time or another. I've now been here almost 12 years. This is Chuck Long, Solutions Engineer. And as we move forward, and Ellen, you gave me control, right? Okay, there we go. Our agenda today, in the crazy software-defined world that we live in, we're going to get back to basics. We sell connectivity. That starts all our other sales. So we're going to get back to connectivity. We're going to get back to layer one, as we say, because this is the OSI model we're going to be covering today. We're going to go through all the layers, but as we go through the layers, we're going to take a view, non-technical and a technical view, as well as what applications and what AireSpring products, obviously this is an AireSpring sales session, fit in those layers and how they interwork with them. By all means, all questions are open. As you can see here, standard OSI model, physical up through the application, and little history. It's actually, Ellen, we have a birthday, 40th birthday. I did confirm that the paper was submitted in '83, but was actually approved in 1984. The Open Systems Interconnect or interconnection model that we're going to be talking about today, and implements it for computer networking, telecommunications networking, the 7-layer DIP as I learned it in my engineering days. The goal of this is to be able to everybody to communicate, all devices be able to communicate with standard protocols, no matter where they're at in the world, no whether for using them, making them, manufacturing them, selling them. We're all in the same marketplace using the same terminology. Because usually in our marketplace, it's the terminology that gets us in, what was he saying? You know, that kind of stuff. We're going to be talking about protocols, and I'm going to try to define every acronym, every TLA, 3-letter acronym, 4-letter acronym, every term in here so that you can learn, use this for reference for later by all means. Protocol in networking terms is a standard negotiation or rule between two devices on the network, or what they call entities. It, you know, hello, I'm Chuck, and you answer back. We have protocols when we answer the phone or when we send text or whatever. It is a standard. It's been around, like I said, now for 40 years. It's the X200, and it's the basic 7-layer model that you see here. I always learned it as, please do not throw sausage pizza away. So that's how I learned it. Everybody has their own little acronyms for that. What is the 7-layer OSI model? How is it used? What are we using it for? Send information between two network entities, as we mentioned. But in this case here, we're going to have a user send an email to another user. A lot of the engineers call that layer 8. You know, the problem between the mouse and the keyboard. You know, it's the user's fault, that type of stuff. We all been there. So what happens? I'm on the left side here. I'm going to send an email down through the application layer, down through the presentation, all the way down till I get to the physical layer. Then it goes right back up the stack, as we would say, to the receiver of my email, and everybody's happy because the email was sent and received. As the information is sent from layer to layer vertically, headers are added to the information so it can get to the receiver properly. When the receiver receives the information, it removes the headers as it passes the data back up to the top. A lot of people use the analogy of an envelope with a letter and a stamp and all those, and there's many out there. But I just wanted you to have a reference of what the layers are, what they call them, and what they use. And we'll see as we go into each layer, the bit layer, the frame layer, the packet layer, and then the upper layers all use data. Pretty straightforward, good for reference. Let's start with layer 1, the physical layer, the physical medium. Now, remember, our goal is to communicate. So I'm going to transmit to your receiver. As a human, I am a half duplex analog device with 2 receivers and 1 transmitter. The key word there is half duplex, as we'll see. The physical layer, what are we using? Is it wireline or wireless? Is it copper? Is it fiber? If it's wireless, is it satellite? Is it low orbit? Is it high orbit? Is it wireless fidelity? You know it as Wi-Fi. All these different types of mediums are out there now today. Where I first started this in the 80s, we didn't have all these different types, but we just had a lot of different physical electrical connections. So what are we doing at layer one? Converting ones and zeros to these mediums so we can transport them to the other side or to the receiver. We have electrical. You all know them as Cat5, Cat5e, Cat6, Cat7, Ethernet cabling. In the past, we had all different RS-232, R-422, T1, PRI, all these different, pretty much now everything's pretty much Ethernet. So we're concentrating on that, what's going on. Big development in Ethernet though. That's why I have to mention it, spend a little time on it. 802.3BZ. Okay, Chuck, you're talking in numbers again. There's a new interface out since 2016 that makes life easier between the access points for Wi-Fi and their physical connection to that network. Using that same Cat5e cable that you only could get a gig, now with this new, they call it multi-gig 802.3BZ interface, you can now do 2.5 gig speeds on the same cable. Yes, it's too good to be true, on the same cable. So now I can get twice the speed, 2.5 times the speed without changing any infrastructure. That was a demand because the speeds of the access points on the Wi-Fi sides keep going up on the wireless side of them, meaning more backhaul. So we're able to do that with 802.3BZ. If you had a Cat6, you can go all the way up to 5 gig on that existing cable. So that was a big development. The rest we kind of saw last time. Fiber is pretty much all single mode, little multi-mode, but most of that's at the co-location where all the carriers meet, one Wilshire, Stemmons, Chicago, New York, Dallas, Atlanta, all those co-locations where AireSpring is at. The GPON, the XGS-PON, passive optical networking folks, a lot of broadband using that. It's how you're getting better broadband speeds, higher broadband speeds at lower prices because of that technology and their coherent transceivers. And of course, on the wireless side, our own Mike Chase, my boss's boss's boss, was doing some testing with the new Fortinet Wi-Fi 7. It's supposed to deliver up to 46 gig now wireless from a technical point of view, but there you can see those speeds. So even at Wi-Fi 6, you got potential almost 10 gig of wireless coming back. You're going to need those higher speeds to backhaul them. So that's the physical layer. As you can see, it's moving around. We're layer one experts, I like to say, kind of laugh, chuckle. Why? Because that's what we resell. We resell through QuoteSpring, Agent Star, that diverse connectivity every customer should have to that entity on the network. We do that with our connectivity with all our different carriers that we have, but also with the QuoteSpring, so you can get that diversity that is truly diverse. You don't want to make sure AT&T is reusing Comcast or vice versa. We have the QuoteSpring to do that. Now, a lot of questions come to the solutions engineering team about fixed wireless. First of all, it's wireless and it's not moving. It's fixed, okay? Make sure of that. It's very basic, but that's what we're back to basics. That wireless could be a fixed cellular connection. It could be a fixed satellite, most satellite are, or it could be a microwave line of sight. We have offer all these, get them through QuoteSpring, but realize it is fixed. A lot of people forget, well, Chuck, they're going to move. No, it's fixed. But that's the main thing we want to say here. And you're seeing the cellular fixed wireless, the T-Mobiles, especially coming out there attacking the home front in that area. And of course, at layer one, with all our SD-WAN products, we offer hardware redundancy. Yes, the hardware, your VeloCloud, your Fortinets, your Cisco switches and routers that we use can come in HA mode or an off-the-shelf mode as well. But the off-the-shelf is primarily for our ADTRAN SBCs and 908s. Layer one's our universe, multi-access. Get into QuoteSpring, channel manager, agent star. You get in there and look at that quote, see what's out there. The buffet, speaking of a buffet, look at all those access option, carrier options you have, whether it be the 2PI-Fi, microwave, of course, good old AT&T, and any other local you might have out there, you might want us to hook up with, do some business with, let us know. We're very open to that as well. Now, layer 2. Layer 2 and layer 3, we're going to have two angles at. We're going to look at a non-technical view, then a technical view. Layer 2 is probably the most understood layer out there. Its job is going to kind of organize those ones and zeros going over that medium. But from a non-technical viewpoint, layer 2 is very easy. We and you have different ends of a garden hose. I have my end, you have your end. I'm looking down the one, you're looking back. Whatever I put in the hose comes out your end. Whatever you put in the hose comes out my end. If the hose should break or crack, we lose what we put in. But it's private, it's usually point to point. That's layer 2. Now, what we put in the hose might be a multi-point protocol, it might be SIP voice or whatever, but everywhere where you're at, from where your premises to your POP, more or less have a point to point for your underlying carrier. The technical side, we like to call it the data link layer, DLC. We run a polynomial that puts the ones and zeros in order so that when I send it from the transmitter to the receiver, if I lose any of those ones and zeros or they're out of order, I know that with this framing of the data link layer. Also, this layer is very important because it decides how fast we go. In Ethernet, which is about 99% of what we use now, how fast it goes, 10 meg, 100 meg, 1 gig, 2 gig, 10 gig, 100 gig, 800 gig, they all use the same single mode fiber, maybe different wavelengths. What changes is the gap between the frame. Bigger gap, slower rate. Smaller gap, faster rate. That's how Ethernet works. Very familiar, you get your MAC address at this layer on the NIC card, media access control on their network interface card. Run your 802.3, as we can see here, you're off to the internet. Examples of layer 2, we offer layer 2 point-to-point services through once again, through our quote spring and all that. Big hit, very popular with our large SIP trunk customers, contact centers, and dialers out there. They'll get a layer 2 AireSpring connection. We put our private IP addresses on it, blast all the SIP traffic to us, and off you go. Very popular. Now, layer 3 brings in the network layer. Now, one of the downfalls of layer 2 was, remember, if that hose should break or crack, it's done. Got to go get another hose. With layer 3, I'm going to use that layer 2 connection that's point to point between me and the carrier, underlying carrier's POP. So then we get the premise to POP, point of presence connection. But now when I look through that garden hose, I can see you 4 different ways. This is where we get the term geo-redundant, because if one of those ways should break, I can use one of the other 3. And this is very critical at the network level because you want to have diversity at the layer 2 connection along with geo-redundancy at layer 3. Now, from your prem to POP, POP to prem, you're totally diverse at layer 2 and layer 3. That's what we try to do here at AireSpring, provide that diversity. Because why? We're expecting one of those to break. And we've got it covered. It's in the plan. So that's the non-technical view that between these two, transmit and receiver, I now have, as we can see here, 4 different ways to get there in case one of the ways break. Key thing I want you to remember here for the non-technical, layer 3 is geo-redundant, layer 2 isn't without another physical garden hose. The nerd side, layer 4, the technical side of layer 3, network's a meeting of every node connected to which every other node has an address. We are now addressing each node and entity on the network so it can talk within the network and outside this network. It will use IP. You say that all the time. It means Internet Protocol. It uses two addressing schemes, IPv4 and IPv6. A lot of examples here. ICMP, IGMP, ICMP, the control message, your ping, stuff like that. We have ping on there, DNS, domain name server, Apple Talk for my boss Clinton there from the old days, haha. And of course, all your routing, RIP, OSPF, BGP, eBGP, IBG, all that stuff is in here at this layer. And the key thing, as I mentioned, layer 3 is geo-redundant. Now, in the world, layers 1 through 3, a lot of people call them the network layers, the network and below, because you can't build a network without some medium and without some framing. So you see a lot of people, oh, that's just a network layer. As we go upwards now, and of course, I'm sorry, I got ahead of myself here, apologize for that. The AireSpring Layer 3 applications, this is AireSpring's wheelhouse. We are a Layer 3 shop, we would say that. Why? We sell you dedicated internet access with IP, with public and private IP addressing, so you can get in and out of the in and out between your offices as well as in and out of the internet. This is where the SD-WAN VRFs are the underlies. The underlay, when you go to your SD-WAN boot camp, Mike Chase boot camp, we got another one next Thursday. If you haven't been to boot camp, get there. But in the boot camp, they talk about the underlay. This is a layer 3 connection. That's why you can use different carriers on that, on your Fortinet, VMware, VeloCloud, as well as your Meraki SD-WAN. And then, of course, some of our older products that manage connectivity with or without internet. For our voice products, they have QoS back to AireSpring, and good old reliable MPLS multi-path label switching there at the bottom with internet access as well. As I said, these layer 3 and below are the network layers. As we now go up to layer 4, why is it not changing? There it is. Oh, sorry about, let me back up here, sorry. We're now going up to layer 4, and I've often struggled to bring up a non-technical view for layer 4, and it's really, it's not a good analogy. It's just, we've had TCP, transmission control protocol, out for almost 40 years, but at layer 4, the networks made their connection. Now I'm going to take a host off of one network and connect it either to a host on the same network or on another network and let them communicate with each other with whatever protocols they want to use. So the networking is done, the routing is done, we're there, we're now connected, these two entities. How are they going to talk to each other? And 90% of the time, well, I shouldn't say that high, it's going to be transmission control protocol. Why? It does error correction. I'm going to send you 7 frames. If you acknowledge you got all 7 frames, say yes. If you didn't get them, tell me which ones you didn't get and I'll resend them. This is TCP. Over here is a TCP handshake. It uses different port numbers to make these connections. These are AINI port numbers. Why I bring this up from a security point of view. When people say, oh, that's the whitelist in the firewall, what they're saying is we're going to allow TCP across because it's on this international list of OK ports to use. These aren't hackers. These are the good people, right? So that's why at the port level now, the firewalls are going to start blocking or allowing traffic. And this is the traffic. TCP, UDP are the most popular. UDP is what we use to send the media in SIP, your voice, your video, when you're in a meeting. TCP is the guy who sets up all the calls for all that medium, as an example. So I'm sure, I'm hoping in schools today, they're all learning TCP. It is amazing how long it's been around, but it is quite crucial because networking protocols use it, client server, server, all these different entities, your Wi-Fi, everybody's uses TCP. It's having a little delay here on the, why doesn't it? There it is. This here is more for your reference on this slide. It shows a handshake down in the notes section if you really want to get into it, but it makes the world go round, or one of the things that does, as they say. And all right, let's click. I'm having a little delay here myself here. Ellen, you want to click it for me there? Thank you. Now, thank you, Ellen. An example of layer 4 is the SD-WAN connection. The infamous Velo Cloud DMPO, dynamic multipath optimization, is a tunnel between the two nodes running their own version of TCP that's encrypted so that we can do all that dynamic multipath optimization. Fortinet, they have their AVPBN, but anybody who's using SD-WAN, making that proprietary tunnel connection for their SD-WAN, is a layer 4 example. An end user example that's very popular, makes us a lot of money, is the AireSpring ASIP mobility product. And of course, what we do there is we take an AireSpring public block, put it behind our SD-WAN product, route it from the gateway to the edge. Why? Now it's protected, and that mobility for any remote users, they now just have to go at our IP. Doesn't matter what the underlying loop is. This is basic stuff in the boot camp. So yeah, you can click the next slide. Oh, let me see if I can do it here. But there we go. And typical picture of them all combined here at layer 3, layer 4. You have the underlying layer 3 loops going to the SD-WAN device, running a tunnel over at layer 4. Then on top of all that goes our SIP trunks, AirPBX, and all the family favorites. So that's where it all ties together there. Now, as we go up from layer 4 is the most attacked layer from a security point of view. Why? Because it's setting up all the connections of the host to host. It's letting the network do all the hard stuff. Then so we have to keep that in mind. As we go up, you'll see more and more attacks, and we have a slide at the end showing that. And of course, as we move up to layer 5, this is SIP to us here. Just SIP it, as we say here at AireSpring. Does do billions of calls per month. Session initiation protocol. Can't make it any more straight. This is what I like. Why? It's at layer 5. It's the session layer, and this is its initiation protocol. Straightforward. Go set stuff up now between these two hosts. Now you can have multiple sessions doing stuff. So one of the things that we do at layer 4, we take all these different sessions and multiplex them together as well. Other things, voice, video. Our meeting right now, we're having a layer 5 session that you all join via your layer 3 and layer 4 connections. And then when you're logged in and now you're sharing the video at layer 5, it's sharing all the video and the voice that you're hearing and seeing. And of course, here's a classic B2B UA here on the right for your reference. Back-to-back user agent. We do that with our 908 ATRANS. Can't be a Chuck Long OSI without a SIP Wireshark trace. This basically is showing you the SIP session, doing the handshake. It says okay, it acknowledges the okay, you start talking. Showing off all our SIP products there well, SIP trunk, PRI, Microsoft Teams can be a part of that SIP trunking product, 8x8, AirPBX, and we can secure all that over the top via TLS SRTP if you need be. And of course, that is transport layer security with secure real-time protocol, that type of stuff there. So as you can see, it works out nicely. Layer 6 and layer 7 are more where the application people kind of take over. If you're an application programmer, HTML programmer like that, these are the strings that you put in your program that come down to the presentation to make sure that when I log in, I get it in ASCII and it's in English, or ASCII and it's in French or German or Italian or Chinese or Mandarin or Spanish, whatever, these type of things. The most popular layer 6, though, of course, now is the multi-purpose internet mail extension. Oh, you don't know it that way? It's called a meme. Yeah, you guys all know the memes. We've made those famous like that. The irony, too, is the most popular layer 6 that you use every day, and you use it constantly, is when every time you do an HTTPS connection, that's 90% of the internet, you're using a secure socket layer at layer 6 to do that. So yeah, it's kind of neat. It's the pretense you're using case or SACE trying to do, if you're doing a remote desktop terminal, this type of stuff, different applications, you're presenting it to the application. And then finally, ASCII code, Chuck's got to get it. Matt Damon made it famous in the movie The Martian. That's how he got home. You know, basically, we're taking characters and changing them into numbers. Just as DNS takes your AireSpring.com request and changes that into an IP address, here for the end human or human here, we're changing it into a character they can understand. Layer 7 is all the protocols we use, HTTP, FTP. If anybody, and these are all kind of acronyms coming at you now, SOAP, Simple Object Address Protocol, Hypertext, I can't remember, I forgot about HTTP, Hypertext Protocol, I believe. The POP3, SMTP, and IMAP, all you need to remember, if anybody says POP3, SMTP, or IMAP to you, they're emailing. Keep it simple. It's all their, some form of email or doing it. Then of course, file transfer, trivial file transfer protocol, or secure file transfer protocol, server to server, telnet, domain name service, and simple network management protocol. These are all protocols that you log in and use that use the stack as well. At AireSpring, we have portals that are our applications I like to use, and got some great news coming in the AireSpring portal world. But you have your AirCare, that's a layer 5. Why? It's watching the SIP traffic and it's billing you on that SIP traffic. That's where you get your bills paid. But you can also reroute. I guess we could say it, well, that's rerouting at the DID level. So that's kind of layer 5-ish, I guess. We can go that route there. But it used to be Air NMS. Now Air Monitor and Air Alert. Yeah, lots. I hear lots of new features coming there. Still as solid as a good old Air NMS. Still doing the same thing. Going to give you more features, though, I'm hearing. That's watching layer 1 for 3, all those underlying loops. And whether it's our loop or not, our box or not, it doesn't matter anymore. That's why it's now Air Monitor and Air Alert. It's upped its game. It's nice to see. You get your layer 3 usage. You're going to get woken up at 2:30 in the morning because you told us to do that via a text, via an email, and via a phone call if you want to. Com Portal, Air PBX, or your 8x8. Log into your portal there, whether it's contact center or simple phone usage or soft usage. You got all that in there. You can do, you can look, and we give you an administrator access to forward people's phones who aren't showing up for work today. Quote Spring, we've already talked about. Then, of course, as everybody knows, this is a family tradition here at AireSpring. All our portals are free. We just make you sign some legalese, so if you blow it up, we'll fix it for you at a certain price. We're your co-partner. We're your technical co-partner in this. We're going to make sure that you don't get bamboozled by anybody. And with these portals, if you want read access, it's to look at stuff because you just, you know, you want us to manage everything, it's great. Or if you have a customer that's a do-it-yourselfer that just wants the Lego blocks and let us get out of the way, that's what we're about here. And then I always like to throw this in because it's not SASE, that's SACE. And up at layer 7, this is where you get a lot of virtual file transfers and virtual terminals and manufacturing messaging services. Why am I mentioning this? That's where all the IoT people hang out. They use the MQTT and the MMS to talk to each other in their little world like that. So as you can see, a lot of new things coming on in the portal. Can't wait till you get that new Air Monitor and Air Alert stuff. It's going to be fun for everyone. But if it's a standard, Chuck, everybody uses it. The good, the bad, and the ugly, as they say, right? So here, this is, if I was teaching a hacking class, I don't know if I'm allowed to say that. If I was teaching a bad actors class down in Hollywood, I guess, or whatever, well, in the physical layer, we're going to sniff and we're going to eavesdrop. What do you mean? Well, eavesdropping's the easy way. Well, back when they were using wires, we'd have to cut the wires or bug it or get on it, right? Well, now they're dumb enough. They just send it from one wireless device to another wireless device. So all we have to do is eavesdrop. And if they haven't changed their SSID password for their Wi-Fi and they're using the one from the carrier that's the serial number, we all get free access. Woohoo, right? Well, once we get in there, we got to spoof that we're not here. So we got to spoof the layer 2 and spoof a MAC address or a NIC card and you know, and then once we get there, we can get in between, man in the middle, woman in the middle, person in the middle, anybody in the middle, I don't care. And now we can see whose networks are everywhere. Oh, look, they're going over there. They're going to Hong Kong. This is great. I do find it ironic that all your best firewalls in the world, including our own Fortinet, if you want to really do deep packet inspection, you have to do a hacker man in the middle attack to get it. But, you know, there it is. And then once we're in the network, we can do reconnaissance. We'll sit here at layer 4, watch all their TCP connections, see what ports they got open. That's why people do port scanning on devices to see where we can go. Then we can finally hijack their SIP traffic like SIP Vicious, you know, the SIP Sex Pistols and all that. Right, okay, bad joke, Chuck. But now at the session layer, I can that way I can get free calls all around the world, right? That kind of stuff. And then we can come down from the top. We can send out some phishing emails. I'm sure everybody stepped on a landmine at one time or another by accident, just to get, so I can exploit you with DDoS attacks at the application layer. So yeah, the bad guys got their ISO model as well.